Welcome to qnawire.
We begin this question by noting that we have to calculate the value of y. And note that, in general, L is much bigger than D. Therefore, this angle theta, which is the same as this angle theta, is very small. Then, because of that, we can approximate y as being L times theta. So now, we have to calculate theta. And how can we do that? We use this equation. By solving this equation for theta, we get the following. Sine of theta is equals to m times lambda divided by d. But again, this angle is very small, so this is approximately theta. Therefore, y is equals to m lambda L divided by d. But note that y is the position of the peak number m. So the distance between two peaks is delta y, which is given by ym minus ym minus 1. And it's very easy to see that this will give us lambda times L divided by d. So the separation we want to calculate is lambda L divided by d. Now, how can I calculate that? We already know what is the value of L, and we also know what is the value of d. Then we have to give an estimation for the value of lambda. To calculate the value of lambda, we can use this relation. So lambda is equals to h divided by p. Then we have delta y is equals to h times L divided by p times d. But we don't know what is the value of p, the momentum of the particle. But remember that the energy of the particle is equals to p squared divided by 2 times the mass. So we can approximate p as 2 times m times z under a square root sign. Therefore, delta y is equals to h L divided by the square root of 2 times m times z times d. In this regime, the energy of the proton is just its kinetic energy. So, finally, we get an expression for delta y, which is the square root of 2 times m times k, the kinetic energy, times d. This is dividing h times L. Now, all we have to do is plug in the values that were given by the problem. By doing that, we get the following. Delta y is equals to h, which is 6.63 times 10 to minus 34 times L, which is 18, and this is all divided by the square root of 2 times the mass, which is 1.67 times 10 to minus 27 times the kinetic energy, which is 650 electron volts. But we have to convert this energy from electron volts to joules, and we can do that by multiplying it by the electron charge, which is 1.6 times 10 to minus 19. And this is all under a square root. And finally, we multiply by d, which is 0.8 times 10 to minus 3. Then, this results in delta y approximately 2.5 times 10 to minus 8 meters.